Hi, Assalamualaikum everyone. In this video, I'm gonna talk about the last subtopic in this chapter, which is at point 4, conservation of angular momentum. There are two learning outcomes here. First is to define and use angular momentum. Second is to state and use principle of conservation of angular momentum. Okay, so we're going to talk about momentum here. So this term you are familiar with because we learned in chapter 3 before about momentum. Okay, so just a little bit of recap here. Okay, dalam momentum chapter 3, which is we call it as linear momentum, we know that momentum is equal to mass times with velocity. So any object with mass that is moving in any direction akan ada momentum. So sama juga dalam rotational motion. So any object that is rotating, will have momentum. So now we call it as angular momentum because the object yang rotate akan rotate dengan angular acceleration. So that's why kita panggil dia angular momentum. Okay, so angular momentum, by definition, it is the product of angular velocity of a body and its moment of inertia about the rotation axis. So dekat sini, angular momentum, kita akan gunakan simbol L. So this is angular momentum. So angular momentum is the product of inertia and angular velocity. So basically, inertia ni adalah equivalent of mass di dalam linear momentum dan angular velocity adalah the equivalent of velocity. And the unit for angular momentum adalah kg meter square per second. And it is a vector quantity, meaning that there will be a direction here. Okay, now we're talking about principle of conservation of angular momentum. Before this pun kita sudah tahu, we learn in linear momentum, that the sum of the momentum initial will be equal to the sum of momentum final if the sum of the forces acting on the body is equal to 0. So conservation of momentum, dia punya condition dekat sini, dia mesti there is no force acting on it. So sama juga dekat dalam angular momentum. So the total angular momentum of a system remains constant if the net external torque acting on it is equal to 0. So kalau the sum of the torque sama dengan kosong, the momentum will be constant. So apabila constant, the sum of the initial momentum will be equal to the sum of final momentum. So here, because we know that momentum sama dengan I omega, so maksudnya I omega initial akan sama dengan I omega final. So depends dengan situation. So kadang-kadang ada situation dia punya inertia tidak akan berubah. Tetapi akan ada situation inertia dia akan berubah dekat final. So depends pada soalan lah. This one nanti kita akan tengok dekat dalam video example. How do we use this formula here? Okay, so the concept here for the angular momentum. So kita ambil contoh spinning ice skater. Okay, so kita ada dua situation dekat sini. Satu, the girl is spinning with her arms wide open. So dia buka besarlah dia punya tangan and then dia spin. And then satu lagi, dia tidak buka dia punya tangan. Dia just peluk tubuh and then dia spin here. So we want to compare here the moment of inertia in each situation. Okay, let's say the mass of the girl is the same. Samalah mass dia, let's say lah 50 kg. But the moment of inertia will be different because kita tahu moment of inertia adalah sama dengan mr square. So mass constant, tetapi value of R will be different because value of R ni adalah daripada axis of rotation. Distance daripada axis of rotation. So here, axis of rotation adalah dekat tengah kan. So the value for R here, there is a certain value here. So there's a certain value, maybe 2 meter. Let's say lah. So dekat sini pula, dia punya value for R sudah decrease. So in here, sorry, ini adalah mr square. So dekat sini kita boleh cakap dekat situation 1, moment of inertia dia lebih tinggi berbanding moment of inertia dekat situation 2. Sebab the value for R is larger than the value for R here is larger than the one in here. Okay, so maksudnya dia punya moment of inertia akan tinggi. Okay, so angular momentum adalah sama dengan I omega. So daripada sini kamu boleh tengok sebenarnya apabila I adalah inversely proportional to omega. So here kamu boleh nampaklah kan sebenarnya I akan sama dengan L divided by omega. So I ni akan inversely proportional to the omega. Meaning that if I increase, omega will decrease. Sebab kita tahu moment of inertia ni adalah the tendency of a body to resist angular acceleration, which sama jugalah dengan angular speed. So if the I increase, omega akan decrease. Maksudnya dekat sini dia lebih susah untuk dia pusing sebenarnya berbanding dekat sini. Okay, sebab omega dia, this one, omega dia lebih tinggi, lebih besar berbanding dekat sini. Okay, the speed is will increase lah in here compared to the one in here. So secara konsepnya kamu kena ingatlah macam tu. So just ingatlah that inertia is inversely proportional to the value of angular speed here. Okay, so nanti dalam video example I will explain about the calculation.